Okay, so this is our solution for the test. The first problem was slightly different depending upon whether you were taking a class in person or online, so I'll do both of those solutions. The first part, the equation y equals x squared minus 8x minus 9. That was the same for both situations. So, to get the x-intercept, you set y equal to 0, solve for x. So we set y equal to 0. Solving for x in this case means factoring it, and you can factor it hopefully by observation. So, what two numbers multiplied together give you 9? Well, 9 times 1. And if I add them together, I'll get 10, but that would be if this were positive. So I'm really subtracting it because this is negative sign here. Well, because of the negative sign here. So one's going to be positive, one's going to be negative. And it's negative 8, so the negative has to go with the larger of the two. So I get a negative total. So, x minus 9 equals 0. If this goes to 0, then the product goes to 0. So you can solve for the 0. And the same way here, x plus 1 equals 0, or x equals negative 1. So those are the x-intercepts. If you did that, that's fine. You could do 9 comma 0 and negative 1 comma 0 as the points. Now to find the y-intercept, you set x equal to 0. Solve for y. In this case, you don't have to solve for y because it's already solved for y. So you put 0 in, which means for polynomials it's just the constant term, because the other parts of the polynomial go to 0. So you get y equals negative 9, or 0 comma negative 9. You can see over here y equals 0, y equals 0. So things we specify are x. So that was that one. Now for the in-class people, as you know, I changed it in class, and don't worry, online students, I basically give you 5 free points there just because you may have got confused here. So I think in class I changed this to plus and this one to negative. And I changed it on my test, and I forgot to change it when I took the test and realized, oh, I really wanted to have this. But one thing, just to kind of give you an idea of here, what is this square root function? How do you shift this? Well, you'd go negative 2 in the y direction and negative 9 in the x direction. So you'd start over here, and because it's plus square root, it's going to just follow the normal trajectory. So you end up with 2 intercepts, one x-intercept and one y-intercept. So the same thing applies to find the x-intercept. You set y equal to 0. So you'd have 0 is equal to the square root of x plus 9 minus 2. And then you would bring the negative 2 over to the other side, make it positive. And if you square that, you'll get 4. On the left-hand side, you'll get x plus 9. So you get x equals negative 5. Subtract 9 from both sides. So that's your y-intercept, where y equals 0. It's your x-intercept, where y equals 0. So you're going to have negative 5 comma 0. And then the y-intercept, you set x equal to 0. So you get y is equal to the square root of 0 plus 9 minus 2. And the square root of 9 is 3, so you get 3 minus 2, which is 1. So the y-intercept is going to be 0 comma 1. Now, for the online students, I gave you, since I couldn't change it and I already distributed it, it was this. So if you plot this thing, the start of the square root function is going to be at negative 2, and then positive 9. So it starts over. Actually, no, it's going to be positive 2, positive 9. So it starts right here and it goes up like a normal. So you can see there's no way that it has any intercepts. So that would be one way. If you just said, you know, the way this graph looks, there's no way I can have an intercept. Now, how do we know that's the case? So let's do the y-intercept first. So for the y-intercept, you set x equal to 0. So you get y equals the square root of 0 minus 9 plus 2. Y equals the square root of negative 9 plus 2. And you'd say, I can't take the square root of a negative number. So this does not exist. Therefore, there is no y-intercept. From the x-intercept standpoint, it's a little trickier, and that's why I gave you this one. I expected you to realize that it doesn't exist. This one is not quite so obvious. You know, you'd set that equal to 0, and what you might be tempted to do is subtract 2 from both sides and then square it. So when you square negative 2, you get positive 4. Now this is incorrect, and I'll explain why in just a second. Well, it's incorrect because I did it wrong, but so if you square both sides, you get that. And so you could, you know, you'll get x equals 13, I guess. Is that right? Which is not true. And the problem here is when you get to this point, that there's the square root of any number is going to be positive. So there's no way you can get a negative 2. You know, you can't. What you're doing here is you're finding out what number do I plug in there to get positive 2, which would be 13 minus 9 would be 4. Square root of 4 is 2. But at this point, you'd have to say, you know, the y-intercept does not exist again because of this issue. And like, I didn't take off for that, so it's not quite simple. Okay, number 2. So I said I wanted a line that was perpendicular to this line. So all you had to do is say that the slope of a line perpendicular to this is going to have the negative reciprocal. So you'll take the negative off, turn it upside down. So you get a slope of 4. So you have the slope, and then you have the point, which is negative 2, 3. So all you have to do at this point is use the point-slope form of the linear equation to plug everything in and then just solve the algebra. So in our case, y1 was, so we're going to subtract y1, which is 3. We have the slope 4 times x minus x1, which is negative 2. So when we subtract a negative 2, we're going to get positive 2. Then you distribute the 4, so you get 4x plus 8. And then you'll add 3 to both sides, or you can think about moving the 3 to the other side. Make it positive. So when you add 3 to both sides, you'll get that. So you get 4x plus 11. So that's your answer for number 2. As far as points, the first 2 problems were worth 20 points. Okay, the next problem is I give you 2 points, and I asked you to find the slope of any line that's parallel to this line. Parallel lines have the same slope, so I needed for you to explicitly say the slope of a line parallel. So there was, if you didn't do that, that was 5 points. Okay, so you've got 2 points, negative 2, negative 1, and negative 5, 3. So some of you did this, some of you didn't. A lot of the ones that didn't do this got it wrong, so I put in this, written this out explicitly, so when I calculate the slope, y2 minus y1 over x2 minus x1. So y2 is 3, y1 is negative 1, x2 is negative 5, minus x1, which is negative 2. So I'll get 3 plus 1 divided by negative 5 plus 2, which is 4 divided by negative 3, or negative 4/3. So you need to write lines parallel have a slope of negative 4/3. Okay, so now that you have a slope, you can use the point slope form, and I'm going to use x1, y1 here. You could use the other one if you wanted to. You should have gotten the same answer. So you take y minus y1 is equal to m times x minus x1. Y minus y1, negative 1. Slope is negative 4/3 times x minus x1. x1 is negative 2. Okay, so you get y plus 1 is equal to negative 4/3 times x plus 2. Then you distribute the negative 4/3 to both terms, so you get negative 4/3 x, and you get negative 2 times 4 is 8, so you get negative 8/3. Then we can subtract 1 from both sides. I'm going to do the same thing, but just move this from left to right. It becomes negative 1. Then I'm going to convert these two to a common denominator, which is going to be 3. So 1 is 3/3. So you get y is equal to negative 4/3 x. Negative 8 minus minus 3 is negative 11. So you get negative 11/3. So that's your answer. Okay, number 4. So that was worth 20 points as well. Number 4 says find the zeros of the following equation using completing the square. So some of you knew how to do it not using completing the square. So it was worth 20 points. So if you use completing the square, well, of course you got it right, but if you didn't use completing the square, I give you 5 points. Because that's the whole purpose of the problem, is using completing the square. So what you do is you take the terms of the variables and separate them from the other one. You take this coefficient, negative 6, divide by 2, and you square it. So let's do negative 6 divided by 2 is negative 3. Negative 3 squared is plus 9. So we add 9 here, and we subtract 9 there. Now, the complete square is going to be x plus whatever this is. So it's going to be x plus a negative 3. Quantity squared. And then you have negative 16 minus 9, which is negative 25. So that's y equals x plus 3 minus 3, sorry. So I'm adding a negative 3, so that's going to be minus 3. Minus 25. Okay. Now to find the zeros, you're going to set the expression equal to 0. If this term is not negative, then you're out of luck. There are no zeros. But in the case, here it is. So when you move it to the other side, it becomes positive 25. Take the square root, so you get plus or minus the square root of 25 is equal to x minus 3. The square root of 25 is 5, so you get plus or minus 5 here. And then you add 3 to both sides. So you'd get x is equal to 3 plus or minus 5, or x equals 3 plus or minus 5. So the two solutions are 3 plus 5 and 3 minus 5. So it's 8 and negative 2. If you go back to the original one, and you see what you get here. These are the zeros. So the factors. The factor associated with x equals 8 is x minus 8, and the factor associated with x minus 2 is x plus 2. And if you check it out, you'll get your right answer. So x times x is x squared. Negative 8x plus 2x is negative 6x, and negative 8 times positive 2 is negative 16. So that's how you use completing the square. Okay, the next one, show an odd function and an even function. So the easiest ones to do for an odd function is the y equals x cubed, and the even function is y equals x squared. I didn't require you to do that, but those would be the easiest ones. And so how do you use what characteristics of the function let you know whether it is an odd or an even function? So this is the function. So, or you could look at the graph. One here, you could say f of minus x equals minus f of x. And here you would say f of minus x equals f of x. So that's one thing you could say. So when you go, you can also say symmetric across y-axis. So that's even functions. Here you could say it's symmetric for the origin. Or you could talk about this exponent, this being odd, this being even. So those are what I was looking for there. So the drawings were worth 10 points and the explanation was worth 10 points. The next problem is only worth 10 points. And all you have to do is just factor it. It tells you to do that factoring. So hopefully you know how to do factoring or you're in trouble. Okay, so how do we factor this without using the quadratic formula, completing the square? Well, in this case you can, because what two numbers multiply together give you 21? Well, you'd say 1 and 21 and 3 and 7. So obviously it's important to know how to factor something. And if I add, because this is a positive sign, they're either both going to be positive or negative. So I would look at the sum of the two. If I add this to there, they get 22, and if I add those two together, I get 10. So this number either has to be 10 or 22. We can see it's 10. So these are the two factors, 3 and 7. And they have to be the same sign, and they have to be negative. So if this was plus 10, they would be x plus 3 and x plus 7. But because that's negative, they have to be negative. Now that's the factoring. But then the factors have to each go to 0 for this product to be 0. You can have 0 times something is 0, or something times 0 is something. So you set these factors equal to 0, solve for x. You get x equals 3 and x equals 7. So those are the zeros of the polynomial. Okay, so the next couple, it says state the parent function, which means write it down. Then the transformation, so I want you to write down, it says write them out, the x shift, y shift, reflections. Plot the function and the parent function. Use the dashed line for the parent function. Okay, so here we go. Here's your function. And remember, all of these are, x minus h squared plus k. There's this coefficient out in front as well. But in terms of the shifts, negative h equals plus 2. Negative h equals plus 2. Or h equals negative 2. Okay. and in this case, k is just read off directly, so it's 4. So let's write the parent function. So the parent function is the squared or quadratic function. And the transformations, we have the shift, so shift x minus 2, or to the left if you want to say left. Don't do both of them because you're going to double dip there. You can say shift y plus 1 or plus 4, which is up. Left 2, or we could say up 4, either one. Now, because the negative sign is outside the argument being x plus 2, what that means is it's going to be an x-axis reflection. Okay, so let's look at the graph. Now, one thing, I asked you not to use your calculators to graph these things, but I think some of you did, and I'll tell you why. So, you know, I can't watch every person. If I didn't let you use calculators at all, then you'd be really sad. So I was hoping that you would stick to it, but I'll explain why I did think some of you did. Okay, so, you know, the quadratic function, the parent function is 0, 0, and we've talked about, you know, some key points. X equals 1, so you plug 1 into the parent function, you get 1. So you get 1, 1 squared, 2, 2 squared, which is 4, 1, 3 squared, which is 9. And then you have the symmetry around the y-axis. So that's your parent function. You could just draw it in with a dashed line like this. Okay, so now what you're going to do is you're going to shift this vertex. That's kind of like the anchor of this whole thing. So we're going to shift it 2 to the left, up 4, which puts you right there. But we have this x-axis reflection, so instead of going up like this, it's going to go down. There is no stretching, so, you know, I go over 1 and up 1 here, so I should go over 1 and down 1, over 1 and down 1. Like here, up over 2, up 4, over 2, down 4, over 2, down 4, and then I could do 9. So over 3, down 9, 1, 2, 3, down 9, that's 4, 5, 6, 7, 8, 9. And do the same thing here. You can see how these are symmetric, and then you can draw your thing in. Okay. Now that's not the one that I had questions about, people plotting it and then trying to figure it out from there, you know, what the shifts were instead of using the equations. Okay, so the next one, which is 8, g of x equals the square root of negative x plus 4 minus 3. Now the first thing that bugged me was the people who got it right, but they didn't do what they're supposed to here. So you factor out the negative sign. I don't know how many times I got to tell you guys that, but you factor out the negative sign from here. And at this point, you can use the rules that we've learned. So the people who didn't factor that out got this in the wrong direction, usually, if they didn't use their calculator. If you did use your calculator and you didn't do this, then I think you did use your calculator. Okay, and the last problem confirmed my suspicions. Okay, so once you do this, then you can look at all the shifting in the reflection. So, you know, this is x minus h. So in this case, negative h equals negative 4, h equals 4. So we're going to have a positive x shift and then k plus k. So in this case, k equals -3. So what we can say is x shift is going to be plus 4, or 4 to the right, and the y shift is going to be -3, or 3 down. Okay. And this negative inside, this negative here means y-axis reflection. So let's get a piece of graph paper out. I think next year I'm going to say, if you don't do this, I'm going to put the hammer down or something, because I say it and nobody ever listens to me. Okay, anyway, here we go. The parent function. So the parent function, let's write that down. Parent function is square root of x. So the square root of x starts at 0. Can't have negative, square root of negative numbers. The square root of 1 is 1. Now, because I'm taking the square root, I need two perfect squares. So what are the perfect squares? 1, 4, 9. So I go 1, 2, 3, 4. Square root of 4 is 2. That's the y value. Square root of 9 is 3. So that's my parent function. Now, I'm going to shift 4 to the x, -3 to the y. So that's my new starting point. And this is going this direction relative to the y-axis. So I'm going to go the other direction. So I'm going to go this way. I'm still going to go up because I'm doing across the y-axis. So I should go like that. So you do the same things. You go over 1, up 1, but instead of over to the right, you're going to go over to the left. So you go over left 1, up 1. 1, 2, 3, 4, over 4, up 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you go over 9, up 3. Square root of 9 is 3, and then you draw it like that. Okay, next one. G of x equals negative the absolute value of negative x plus 3 minus 4. Okay, factor out the negative sign inside the argument. Okay, x minus h plus k. So -3 equals negative h, or h equals 3. And here we have k is equal to -4. So, make sure this is equals that. So the shift x shift, it's going to be plus 3, or 3 to the right. The y shift is going to be minus 4, 4 down. Now here's another reason I think you guys plotted it and then tried to figure it out. So if you plot this is an absolute value function. So the parent function is the absolute value of x. So if you plot it, you see it shifts across the x-axis. But because it's symmetric, you don't see the shift, you don't see the reflection across the y-axis. So if you'd done this and you looked at these two numbers instead of just plugging it into your calculator, you would have realized that there were two reflections. So, of course, I can't definitively say that you used your calculator for that, so I'm not going to take anything off except for the errors you made. So you'll see that I took 2 points off for not factoring this out, especially if you got the shifting right. So Anyway, so what there's x-axis and y-axis reflections in this case. You really only see the x-axis reflection because of the symmetric nature of this particular function. Okay, so the parent function starts here at the origin, like all the other ones, goes diagonally right up through here. So you have to go straight through there, the same way the other direction. So you could go over one up, one over, one up, one over, one up, one. You know, if you want to just make sure that it goes all the way through these things diagonally. So that's my parent function. I should have used the dashed line there. But now I shift, so I'm going plus 3 in the x direction, minus 4 in the y direction. So there we are. And the x-axis reflection causes it to go like this. And I'm using a dashed line here, but I'm going to draw on a solid line. It's just hard for me to draw a good solid line to start with. I need some kind of guidance. Now if I do the y-axis, this will go over there and that'll go over there, and you get the same thing. So that's the way that one works. Did I do everything? I think I did. Okay, the next problem is this composite function and the domain. So you're given f of x equals x squared, g of x equals the square root of x plus 2. So let's do the f of x and g of x. F of g of x and f of g of x. So I don't know if I said that right. F of g of x. So you take f of x, and instead of having x, you put in g of x. So you get the square root of x plus 2, quantity squared, and then you've got g of f of x. So you take g of x, where you have x, you put a parenthesis, and so we take f of x and we stick that in there. Now this one you can simplify, because if you take the square root of x plus 2 quantity squared, the square root disappears and you just get x plus 2. And down here you can just take the parentheses off, but that's all you can do. So some of you guys, algebra wasn't so good. So that's as far as you can go. Now the domains you got to be a little careful about. So let's look at the domain of x squared. So again, the domain are the implied domain, which is what we're talking about here, is what values of x can I put in here and it'll give me a result. Well, it's a polynomial. If I have a positive number, I can square it. If I have a negative number, I can square it. So there's nothing that limits. So, you know, you can do all real numbers. Some people use that. I usually use this terminology. Okay, you could say all real numbers. Any one of those is going to be fine. Okay, for the second one, for g of x, you have the square root of x plus 2. Well, for square root functions, the argument, this is the argument, x plus 2, has to be greater than or equal to 0, because we cannot take the square root of number. Square root of a negative number. No two real numbers multiplied together will give you a negative number. Just like up here, when we square a negative number, you get a positive number. So you get x plus 2 has to be greater than or equal to 0. Subtract 2 from both sides. You get x has to be greater than or equal to negative 2. So that's the domain for that. Now the composite function, f of g of x, which is equal to the square root of x plus 2 quantity squared, as I said many times, you evaluate the domain at this point when you do the first substitution, not after you simplify it. Because this function is going to be good for all real numbers as far as the domain, but this one is not, because if I evaluate the function inside the parentheses first, there's a limit on what I can do. So the same, this same reasoning applies for this case. The argument in the square root has to be greater than or equal to 0. So x plus 2 has to be greater than or equal to 0. X has to be greater than or equal to negative 2. So that's how you could, you can show it as negative 2 comma, you have to use a square bracket here. I guess that's the other way of showing domain. So you'd have this, that's one way. So over here, another way of doing this is negative infinity, positive infinity, using these curved brackets. Down here it would be negative 2, I keep forgetting to put the square bracket there, but you'd have negative 2 comma infinity, like that. So that's another way of showing domain. And then you have g of f of x, which is this square root of x squared plus 2. So you say, okay, well, what values of x are going to work? Well, any sine of x, if you square it first, you're evaluating this first, then you're adding 2, then you're taking the square root. So you're going to look at this term and you're going to say, what values of x can I have such that this is, well, you'd actually just say, if I square any number, positive or negative, it's going to be positive. So that's always going to be positive. So you're going to have a positive number plus a positive number, which gives you a positive number. So in this case, the domain for this composite function is all real numbers. Do that, all real, all those would work. So that was worth 20 points, and the domains, actually it was worth 24 points. So the 4 domains were worth 4 points apiece, and the composite functions were worth 4 points apiece. So there were 6 parts to that. And then the last equation, this is another reason I thought you guys used the graphing thing on your calculator. Well, because you didn't know what to do. That's you got it right on the other one, you got it wrong on this one because it's the other way around. And I guess you could have just tried a lot of different things and tried to match up the graphs, but that's not the way you're supposed to do it. So let me put a. So yeah, I got to show you the graph too. So the graph starts here at -2, -2. It goes to here, and then goes 1, 2, 3, 4 to there, and then it kind of looks like that. Okay, so you can see the shift here. It's down to, so it's -2 here, and it's -2 there. It's a y-axis. Here's the parent function, so it's going to look something like that. Okay, let me plot it. 1, 1. 4, 2, 3, 9, 3. Okay, so there's your parent function. So you can see it's a y-axis transformation. So what you have, your parent function is going to be equal to y equals the square root of x. And we have plus or minus the square root of plus or minus x minus h plus k. So this is the x-axis. So that there is no x-axis reflection. So we can use plus there. Then we have, this is the y-axis. So we do have a y-axis flip, so that's going to be negative. And then we're going to subtract h, which is the x shift, which is going to be -2. And then k shift, the y shift, is going to be -2. So you end up with negative the quantity, square root of negative the quantity x plus 2 minus 2 here on the outside. And then if you wanted to distribute that, so you have negative x minus 2 minus 2. Now, this was fine. Some people wrote that out, but I'm not sure how you reasoned your way to that. You really either have to get into this form or you have to start at this form. But you always have to have negative the quantity something if you have a y-axis reflection. Y-axis reflection, put some parentheses in here. Because, what some people did was, I've got a y-axis, so I'm going to need a negative sign there, but I'm shifting -2 units, so I do the opposite. So I'll use +2, and that throws you off, and that's why that's bad. Okay, so this is worth 20 points. So I think there were total 199 points. I did curve it somewhat beyond so the online class didn't do as well as the in-person class. So I don't know whether that was the videos are not as well. You're both watching the videos, so the lectures are the same. The homework's the same. You're seeing the same solutions. So the only difference is I'm in class to help people. And so anyway, you guys are going to have to figure out what you need to do in terms of improving your performance. And I did curve the online class so that I added 5 points back in because of that first problem. So if you have any questions, send me an email.